Our next guest speaker, a feature for today, is the mission manager from United Launch Alliance. He is here today to bring to us talk about bridging history, getting ready to launch astronauts on the UAL's Atlas vehicle. And just thinking backstage about the Atlas, and I'm a little older, but I remember 60 years ago that vehicle being used. And now we are up to date with a much more sophisticated vehicle that our guest speaker will be talking to. Please give a warm welcome and a loud and enthusiastic welcome to Caleb Weiss from United Launch Alliance. Hey, thank you.
All right, well, good afternoon. Thank you very much. It is a true pleasure to be here. I was walking through the Hall of Fame on the way here, seeing the speakers that have been here in past years, as well as those who have been here this year, and to share the stage with principal investigators and NASA directors and famous astronomers is just truly a pleasure. So very happy to be here, and thank you. I am an engineer for United Launch Alliance. I'm not a professional astronomer, but I do enjoy astronomy very much. I find it fascinating. I remember a wow moment for me in astronomy was when I was in college, and the planetarium had a telescope night where they had all the telescopes out on the lawn. And Friday night I went over there, I took my girlfriend with me, and we looked through a telescope that was pointed at Saturn. And you could see Saturn's rings, and that was the first time I'd ever looked through a telescope powerful enough to actually make out features on another planet. And I remember thinking that night, I don't know if I'm more surprised that I just saw Saturn's rings through a telescope, or that I'm a 20-year-old college student who picked to go to an astronomy club on a Friday night and yet still have a girlfriend. So I thought that was really neat, but it worked out well. She's my wife now. We have 2 kids, so it was a success. Anyway, I will be talking about bridging history, as we said. So United Launch Alliance has really started back into human spaceflight, which is great. The rocket on the far left there is our Delta IV Heavy rocket. It has the EFT-1 module on top. So that's the Orion module. That was experimental flight test 1. We flew that with the Lockheed Martin Orion module, took it around the Earth, brought it back in. The rocket to the right of that is an Atlas V 5-meter, 5-meter fairing. That's an unmanned, uncrewed configuration. And then further to the right is the crew configuration. So that is the Atlas rocket that we'll be talking about today. And then on the far left is the SLS. So that is the new, really big rocket that's being produced by NASA, and we are providing the upper stage for the first few missions of SLS. So a lot of exciting things going on with human spaceflight, and ULA is very proud to be part of it, very proud to be supporting a lot of the human spaceflight programs right now. So before we talk exactly about the human aspects, I do want to introduce you to the ULA rockets, specifically the Atlas rocket, since that's what will be carrying crew. We'll start out with the Delta, though, on the left. That's the Delta IV. That's the heavy configuration. So that's 3 core boosters strapped together. It can launch 60,000 pounds to low Earth orbit. So that's approximately 2.5 school buses in weight, and can carry a satellite as large as a school bus in the payload fairing. So a very big rocket, the largest one available in the US today. And then on the right is the Atlas V, 40,000 pounds to low Earth orbit. It's very configurable, as I'll show you in a minute. And that, again, is the one that's going to be launching crew coming up here pretty soon. A little more about ULA. We are headquartered in Denver, Colorado. We have our launch sites at Vandenberg Air Force Base in California, and Cape Canaveral, Florida. So California and Florida. So if you're flying east, going with the rotation of the Earth, you'll fly out of Florida. That's good for LEO orbits, GTO, GSO. If you're going to geostationary, you'll go out of Florida. And then we have Vandenberg. You can fly west in a retrograde or to the south for a polar orbit. So we can hit all the orbits from our 2 launch sites. And then our factory, we have one that builds some of the Atlas parts, fairings, adapters in Harlingen, Texas, and then our main factory in Decatur, Alabama. So operations all throughout the United States, and really great group of people who work at all those locations and love launching rockets for a living. So a little bit more about our fleet. We start out all the way on the left with the small Delta II rocket. It's been a great workhorse rocket. Started out with McDonnell Douglas and into Boeing and now ULA. Very good success record with the Delta II. However, we are phasing it out as the satellites of that size have become fewer and fewer, and mainly flying Atlas V and Delta IV now. So you'll see all the configurations there. We can add different size payload fairings, 4 meter and 5 meter. So depending on how large your satellite is, we'll configure a rocket just for your needs. You know, every pound that you send into space costs money, so we want to try to get you on the smallest rocket that we can, so that we're not carrying a 5 meter fairing if you only have a 4 meter satellite. Same thing with the Delta. You can see different size fairings, and then the big heavy there on the right where we actually put 3 cores together for the really heavy payloads. You also see the solid rocket boosters on the bottom, the white boosters that attach to the side of the rocket, so we can use those for extra thrust off the pad. And the crew configuration that we're going to talk about does use 2 of those. As you can see in the picture, the commercial crew there, about 5th from the left with the Capsule on top, uses 2 solid rocket boosters. So the mission of ULA, we are a rocket company with a very long, strong heritage and a great success record. We merged the Atlas rocket from Lockheed Martin and the Boeing rocket from Delta. The company's been around 10 years, but each of those rockets has flown almost 60. So Vincent mentioned it, that we originally launched a human by the name of John Glenn back in 1962 on an Atlas rocket, and here we are ready to do it again on an Atlas V, which of course is a much improved version. But our mission with those rockets is to save lives, explore the universe, and connect the world. So when we say save lives, we launch a lot of communication satellites, reconnaissance satellites, GPS satellites for the military. So you can imagine communications is vital for them, being able to get data and information around the world very quickly through the satellites that we launch from them ultimately ends up saving lives when they can figure out what the bad guy is going to do before he does it. Explore the universe. So we have had missions to every planet in the solar system. We have had 17 missions to Mars. We've had missions to the sun. So we have enabled a tremendous amount of science data through launching satellites throughout the solar system. And then connect the world. We have commercial missions as well. Last year we launched 2 commercial missions. One was Worldview 4, which is a commercial imaging satellite. So a lot of the imagery that you see on Google Maps or that you pull off or download from online, those are many times DigitalGlobe images that they use from their fleet of Worldview and GeoEye satellites. Worldview 4 was great. It has 31 centimeter resolution. That's the best you can get commercially. It's able to see a license plate on a car, but maybe not read the license plate. So it's very good resolution. And what those companies are doing now with imagery is collecting data from imagery. So that is now supporting thousands of companies throughout the world who buy that imagery and use it to count shipping containers in shipping yards, or airplanes at airports, or watch forests grow, or monitor ice or oceans. And so there's just a tremendous amount of data that can be collected off of satellite imagery. And that's enabled by our ULA launch vehicles putting these satellites on orbit for the commercial companies. We also last year launched an EchoStar satellite that supports the HughesNet service that they are starting. And that's going to provide high-speed internet to rural areas around North America. A lot of areas, even today, still have very slow and old internet access. So we're putting satellites on orbit to help enable them to have faster, better internet. School kids will be able to access more on the internet, do more, get more information. Business owners will be able to access things more efficiently, run their businesses better in those rural areas. But most importantly, people will be able to access Facebook and gossip more in small towns, which is something you can only do over the fence in some of the rural areas around North America today. And then our vision, we will unleash mankind's potential in space. So I just talked a lot about how we do that with the various satellites that we launch, but we really want to be a player and an enabler to getting new missions launched, to getting data about Earth from space, and about putting humans back into space from U.S. soil. So very exciting for us to be able to work in this industry with so many customers, with the Air Force, the NRO, NASA, commercial companies, and really help meet the goals that they have to go do something really cool in space. We have, since our company started in 2006, we've had 118 consecutive successful launches. So if you've ever gotten on the internet or seen on TV a rocket failure, they're not pretty. There were a lot of them in the early days. We thank the people who were working on rockets back then very much for figuring so many things out, and we are now dedicated to mission success. It's our core principle. It's the reason that we've ended up with 118 and counting, and we keep on going one launch at a time, launching them successfully. So this is a collage of all 118 launches. In there, again, you'll see satellites from all sorts of customers. Probably the most famous Air Force satellite you'll see on there is GPS. I'm sure we're all familiar with GPS. But it has really changed the way that we operate every single day. And it's not just on your phone when you pull up a map, but it's tracking vehicles around the world. We actually use it now to track our rocket when we lift off. It's used in ATMs because the atomic clock on GPS satellites is so precise that it marks the exact second, down to the billionth of a second, of when you withdraw money. So your bank is actually making sure that you can't go to 2 ATMs at the same time and withdraw the same amount of money and confuse it. So if you ever tried that and it hasn't worked, you can thank GPS that you weren't able to fool the ATM. But it really has changed the way we do things. A lot of NASA science missions in that collage. LRO Cross, where we crashed a Centaur into the moon to kick up dust and see if we could detect water ice. GLAST, Dawn, SDO, WISE, the WISE Space Telescope, an infrared telescope launched on a Delta II that found 1,000 dust-obscured galaxies and millions of planets. So really an amazing mission there. The dust-obscured galaxies are dogs, which are very bright in the infrared, so they're called hot dogs. But when you think about that, one satellite launched finds 1,000 new galaxies. So just an amazing amount of learning and new data coming off of the missions that we launched. So again, extremely exciting to be part of that. And so to recap that, I'll show it to you in another format in a video. We'll play this and it'll give you a little bit of a feel for what we're doing at ULA right now, what we want to accomplish this year with Commercial Crew, and it'll talk a little bit about our new rocket that we're building as well called the Vulcan. So one of the things that we're working on is bringing the best of Delta and Atlas together into a new rocket. So this is about a 3.5-minute video. It'll tell you a little bit more about what we're doing at ULA, and then we'll get right into the Commercial Crew stuff when we get back and talk about all the great stuff we're starting towards a launch for Commercial Crew next year. So we'll go ahead and roll the video.
Launch director. LD's ready. Stand engineer, proceed with MLP transport to pad.
Roger.
ULA is the world's most prolific space launch provider. We are America's ride to space.
From launching Mercury astronauts, to delivering every operational GPS satellite, to sending every U.S. mission to Mars, ULA's Atlas and Delta rockets have answered America's call to space for nearly 60 years. As a new era dawns, ULA continues to set the pace.
The next couple of years for ULA are very exciting. There's a whole host of things that are going to happen. First, we're going to return to flying Americans to space from American soil.
Scheduled for flight in 2018, ULA's Atlas V rocket will launch Boeing's Starliner on missions to the International Space Station. With the crew access tower nearly complete at Cape Canaveral's Space Launch Complex 41, production and tests will begin this year.
Every mission we launch at ULA is vitally important, whether it's reconnaissance or communications, weather forecasting, NASA science. All of these things enable life as we know it today. What we're doing with Commercial Crew in the Starliner program is taking that heritage and those principles and applying them to the systems that are going to keep humans safe.
We are very excited about the human spaceflight mission, but also we're going to introduce our new rocket, the Vulcan rocket.
Innovation is basically in our minds every single day. We're always thinking about the really great things about both our Atlas and Delta launch vehicles and kind of combining those things and our lessons learned to create this one really great launch vehicle with all of the good things that we have from our heritage vehicles.
Combining a 5.4-meter diameter payload fairing with a powerful American-made engine and up to 6 solid rocket boosters, the Vulcan Centaur will reliably and cost-effectively launch the full spectrum of mission types. With the introduction of the ACES, ULA will forever change the way we think about launch, on-orbit operations, and the possibility of space.
A reusable, very long-duration upper stage is going to allow us to create a fleet of space trucks, a true transportation system that will unlock the tremendous economic value in human potential that exists now just beyond our reach, especially in cislunar space.
Cislunar is the space between the Earth and the Moon, and ULA's vision is to have 1,000 people living and working there over the next 30 years.
Cislunar 1000 creates opportunities for space resources, in-space manufacturing, space pharmaceutical, tourism, and a number of other industries. This establishes a permanent human presence in space.
Innovation is really about coming up with creative and new ways of doing things that shatter prior limitations, and that is absolutely the core of ULA's future.
All right. Thank you. So now you know the rocket company that's going to be launching humans. Wanted to make sure I introduced you to ULA. So very proud to work there, very exciting stuff. So let's get into Commercial Crew. So from Mercury to Commercial Crew, I mentioned again that Atlas launched John Glenn on February 20th of 1962, and now here we are 35 years later, ready to put 55 years later, ready to put astronauts on top of a capsule. So that's the Boeing CST-100 Starliner capsule. Boeing came to us, again, we're a joint venture of Boeing and Lockheed Martin, so in some ways they're buying a rocket from themselves since they are one of our parent companies. But we're providing the Atlas V, we're working with them to make sure that the CST-100 is going to fly safely. We've had to make a few modifications to the rocket, including, most importantly, an emergency detection system. So that's going to be taking thousands of measurements per second around the rocket, and if it detects anything out of the ordinary, there's an option for that system to abort the crew. So this is a much safer configuration than what was flown on shuttle, because we have an option of, if something bad happens on the rocket, we can pop the capsule off and get the crew out of there. And I'll talk about that a little bit more coming up with their abort engines and how that system works. The rocket on the left, the Atlas LV-3B, was about 94 feet tall with 67,000 pounds of thrust. The one on the right is an Atlas V that is 200 feet tall and about 1.6 million pounds of thrust. So a big improvement on the size of the rocket. It does get about 700,000 of those pounds from the solid rocket boosters that will burn for about 90 seconds before they jettison, and then the booster and Centaur will carry it the rest of the way. You'll notice on the left there's the large antenna structure That's not an antenna on top of the Mercury capsule. That is their abort system. So that is another rocket motor that would pull the capsule away from the rocket in the event of a bad situation with the rocket. You don't see that on the Boeing capsule on the right, and that is because the abort engines are underneath, so they'll fire from the bottom, but they'll still do the same thing and pop the capsule off, deploy a parachute, and bring the crew safely back to Earth if there's any issues during ascent with the rocket. Each one of those engines has about 39,000 pounds of thrust, and there's 4 of them, so 156,000 pounds coming at you in almost instantaneously in the event of an abort. So we're certain that the crew will be saved. We're not certain they'll stay conscious during that, but at least they'll stay alive, and that's really the goal, is to get them back to Earth safely and away from a bad situation. So speaking of the crew, here they are. These are the 4 astronauts that were selected for the commercial crew program. They are all veterans of the Corps. All right, I guess you may know them. Bob, Eric, Sonny, Bob, and Doug there. Again, veterans of the Corps. They've flown on shuttle missions. They've flown on Soyuz missions. They were chosen because they bring so much experience and expertise. So they are meeting with us regularly, with Boeing regularly, and with SpaceX. By the way, SpaceX is developing a commercial crew program as well. And they're bringing their expertise to us and saying, you know, I really liked how this worked on shuttle or on Soyuz, or I think this could be improved. And we're taking that feedback and trying to develop the most efficient and safe system that we can for them. So they are vital to the development of these systems. They're extremely fun to work with, and they will fly on the Boeing Starliner and the SpaceX Dragon. The selections have not been made yet on who will fly on what capsule, or some of them may fly on both. That remains to the manifest for each mission has not yet been set. But nonetheless, they're pioneers. They're ready to go, be the first to fly on these new systems, and so we are making sure that we build them the safest ride that we can. They are a good group of people. I'm glad to hear some applause and that you guys recognize them, because if there's a lot of people who don't. I had the privilege of going to dinner with 3 of them a couple months ago. We were in meetings in Florida, and we went out to dinner afterwards, and there was a large group of us, 3 of the astronauts sitting there at the table, and nobody in the restaurant had any idea they were just a few feet away from 3 astronauts. And when you think about how many people would love to sit and have dinner with an astronaut, and the excellent dinner conversation that can be had, it's certainly a stark contrast from the John Glenn and Neil Armstrong days and ticker tape parades. So one of our goals is to really get this new first for NASA right, make these 4 national heroes again, make them recognizable, give them the recognition that they deserve for getting on a new space launch system, or a crewed launch system for the first time, and paving the way for a whole new group of astronauts to be launched into space from U.S. soil. So we very much like them. Another interesting story from that trip to Florida, they were actually unable to attend the first part of the meeting we were having there. So they called in, they joined via teleconference, and we broke for lunch, and about halfway through lunch, they showed up. They were over in Houston on teleconference, and then they showed up at Kennedy Space Center with us. And I said, how did you get here so fast? I already knew, but I wanted to hear it anyway. And so sure enough, they were tired of listening on the phone, I guess, and so they went out and jumped in their T-38s, flew across the Gulf of Mexico, landed right at Kennedy Space Center on the shuttle landing strip, and then walked across the street and came and joined us in our meeting. So pretty nice when you have your own T-38. I told them my experience was similar. I got up at 3 a.m. to catch a Southwest flight. It was almost the same, but not quite, free peanuts. But again, a really neat group of people. That picture there is them in our factory in Decatur. So they're standing next to an Atlas V booster tank that's just finishing production there in Decatur. So certainly a lot of fun and a privilege working with them. How are they going to get on the rocket? One of the other things we've had to do, not just change the systems on Atlas V, but also change the infrastructure at Cape Canaveral. So we have, the way that the system works down there, we stack the launch vehicle in our vertical integration facility, or our VIF. It's our big 300-foot tall building that houses the Atlas V while we stack the various stages. And then we roll it out on a mobile launch platform to the pad. And once it's out there, there's no way to access the top of it. So we built a new tower called the Crew Access Tower, and you can see that that's going to allow them to, it'll take an elevator up, and then they'll walk across that bridge. And there's a white room at the end of that bridge that's kept clean so that we don't introduce any contaminants into their spacecraft. But they'll walk across that bridge and get onto the get into the CST-100 Starliner. That bridge is also a way of getting them off the Starliner very quickly if they need to. So one option, if we ever had to use it after we retract that bridge, if they need to get off very quickly, we can put it back up next to the Starliner within a matter of seconds and get them off safely. The neat thing about the Crew Access Tower is that it was constructed almost entirely off-site in large sections a couple miles away from the pad. This is all at Launch Complex 41 at Cape Canaveral. It's an active launch pad. We launch anywhere from 8-10 launches a year on Atlas out of the pad. And so you can imagine it's not real easy to try to build a large tower when you have an active launch pad right next to you. And so the way that the team did it was built large sections off-site, rolled them over when they were ready, and then stacked this and really minimized the amount of time that they had to be at the pad with doing the construction. So really not just a very neat tower, but also a very cool way of bringing it together and making it happen. So again, if they had to get off the tower very quickly, we now have an emergency egress system. The shuttle pad had this as well. It was a slide wire basket. So the way that system worked is if they ever needed to get away from shuttle, and the reason you'd have to get away quickly would be if you saw something happening on the rocket where pressure wasn't stable or an electrical system was showing some strange readings and you decided, you know, it's probably best just to get them away. Let's not take the time to have them walk across the bridge and down the elevator and out to, you know, send a van to pick them up. Let's just get them away from the rocket as quickly as we can. Shuttle never had to use their system. We don't ever want to use ours. But if we have to, it's there. And we took a slightly different approach, still cables to get them off the tower. But they each get their own individual chair. So there's 20 chairs on the cable. And there's 20 because it needs to cover both the astronauts and the ground crew that's out there supporting them, helping them get strapped in and everything if there's ever an emergency. But this is a commercial system. It's built by a company called Terra Nova. And this was really neat because we went to them, and they are a company that installs zip lines down mountains and across canyons, and we said, we'd like you to come build a zip line at Cape Canaveral and make it into an egress system for our astronauts. And they just thought that was about the coolest thing in the world. They signed right up. And so they came down and really came up with a neat system for us. The chairs on a lot of their other systems are soft and fold. We didn't want that since time is of the essence in a situation like that. We needed a chair that was going to maintain its structure, so they rebuilt us a chair or customized their chair. They put a braking system on so that if you're riding down and you start to get close to the person in front of you, you can brake. And what this will do is it'll take you from that level where you're 169 feet in the air, you'll slide down the wire. You'll go almost a little over 1,300 feet, so almost a quarter mile. You'll take this, and it'll get you well away from the rocket very quickly. It's about a 40-second ride. So when you think about the time from out of the capsule, run across the bridge, slide down the wire, a matter of minutes and you're already a quarter mile away from the rocket. So really a neat system. I would recommend riding one, not this one, but look up Terra Nova. They have sites all over the world, really cool zip lines, and very safe. You know, these are things that people pay to ride. They're amusement, they're recreational, their kids go on them. And so we knew going with a company like that was great because it was commercially available, but it was also very safe and reliable and had been tested in all parts of the world. I mean, again, they have ones in South Korea and all over North America, Europe, Africa. So very tried and true zipline system that they have there. And then if they do have to use it and the situation is somewhat dire and that could be an imminent explosion, and of course I'm just again talking about things we never want to happen, but if it were, at the base, at the landing site for these zip lines is an MRAP. So it's a military vehicle, it's a mine-resistant vehicle, and they will hop in that and then drive about 3 miles away from the pad. So quite a dramatic escape if they ever have to make one. All right, so a little bit more about the rocket. We'll start at the bottom. The RD-180 engine on the Atlas V. That is our highly reliable engine that we have on Atlas. That is one that we will not carry into Vulcan when we develop the new rocket. Vulcan will have a BE-4 made by Blue Origin or an AR-1 made by Aerojet Rocketdyne. Moving up from there, the big copper tank is the booster tank. That holds 25,000 gallons of RP-1 or rocket propellant 1, which is a highly refined kerosene, and 50,000 gallons of liquid oxygen. So the RP-1 and liquid oxygen flow down into the engine, gets combusted, and comes out the back as very hot, very fast gas to propel the booster. We talked about the 2 solid rocket stages on the side, or solid rocket boosters, each about 360,000 pounds of thrust, so that gets you into the 1.6 million pound range for the full rocket. Those will jettison after about 90 seconds. So we'll lift off the pad, those will burn their solid fuel, they'll fall away, the booster will keep pushing the rocket further, and it will eventually then, the booster will run out of fuel about 4 minutes into the flight, and then the booster will fall away. So the idea with rocketry is you want to take as little mass as possible, and so as soon as we run out of fuel in one tank, we want to get rid of it and shed that mass and start burning more efficiently so that we're not hauling a lot of dead weight with us. There's an interstage adapter there in the middle, so that is what attaches the booster stage to the Centaur. And then, of course, the Centaur upper stage. So Centaur has a really great history back to the late 50s, early 60s when it was being developed. And it is, again, the same, it has the same heritage. It's been around since that time. Again, it's updated, it's improved for commercial crew. But it's also, it also has that long success design that went into it in the very early days. It had very strict requirements to be a very reliable upper stage, and it still is. We've made it more fault tolerant. We've built new systems into it, guidance systems, used modern technology with ring laser gyros and new electromechanical actuators for the engine, things that we've been able to build a lot more fault tolerance into than what was there 60 years ago when it was first developed. And then moving up from there is the aeroskirt. Oh, one other thing on the Centaur, it is a dual engine Centaur. So it's been 15 years since we've flown a dual engine Centaur. So it's gonna have 2 RL-10As on it. That's partially to provide the thrust needed to lift CST-100 because it is such a heavy spacecraft, but also for reliability. If we have one engine go down, we have a second one there. So 2 advantages there to have the dual engine Centaur. And really the reason it's been so long since we've flown a dual engine Centaur is that the RL-10 engine was so much improved, we really didn't need the second engine. when we launch the uncrewed missions, a single engine is more than enough to get them to where they need to go. So we eliminated one engine, but now for crew, we're bringing it back. I talked a little bit about the EDS system. You won't see it on here, but again, that was a big change for the crew missions, making sure that we have the ability to detect an emergency on board and get the crew away. That's a huge part of becoming certified and getting the launch vehicle to meet the NASA requirements that are needed to certify for human flight. Okay, so now moving up to the aeroskirt. That was not part of the original design. We had a more tapered design coming around the capsule, and what we found through analysis working with Boeing was that we have this more blunt object off the front. We don't have quite the steep conical that our normal payload fairings are. And so we were getting some pretty bad aerodynamic loads that were coming around that blunt Starliner and slamming into the side of the rocket. So the team went back and said, how can we fix this flow problem? What's going on with our aerodynamics? And came up with this new aeroskirt structure, which keeps the flow going around the rocket longer, keeps it away from that buffeting of coming around and hitting the rocket. So that's a new structure that will be deployed shortly after the booster stage is over. And so that'll be a deployable that comes off about 4.5 minutes into launch. Once we're out of the atmosphere and we don't have the aerodynamic problems anymore, that part will come off. Then at the top, the Boeing CST-100 Starliner. That is the crew module. There's actually two parts to it. The crew module at the top is the conical section, and then at the bottom is the more cylindrical section, which is the service module. So service module has things like propellants, abort engines, things that are needed to get up to orbit safely, but not necessarily to come back. So that service module will actually be separated after the Starliner is on orbit before it comes back to return. They'll get rid of that service module and just bring the conical crew module section back. So that's the conical section is what has the heat shield on it and allows the crew to return safely. The crew module, we have currently 4 missions on the manifest. First one is next year, in June of 2018, we'll fly the Orbital Flight Test, or OFT. That will be an uncrewed flight. So we'll just fly the Starliner, we'll let it dock with the space station, it docks autonomously, and we'll bring it back and just take lots and lots of data, make sure that the predictions that we're making in our analysis are correct, and go back and basically validate all of our predictions. Then 3 months later, in August of 2018, we'll have our CFT, which is our crewed flight test. We'll fly one Boeing astronaut and one Boeing test pilot and one NASA astronaut. So there will be a crew of 2 on CFT. So that'll be our first crewed flight. However, we're not certified yet. We need to get through that flight, do the same thing, go back and validate all of our data, and then we'll start what we call the post-certification missions, or the PCMs. And then we can do as many as we need to of those. There's 2 on the manifest right now, one in December of 2018 and one in March of 2019. So with those, we'll have 4 astronauts on board. The capsule was originally designed for up to 7. The current manifest shows we'll have 2 on CFT and then up to 4 on the PCM missions. So they'll be able to be flexible and really meet whatever the needs of NASA are at the time, whatever the current situation is on the International Space Station, whether it's they need more astronauts, less astronauts, take 4 up, bring 2 back, take 4 up, bring 4 back. We can certainly be flexible. It's a good module for that use, in that again, very safe ascent to orbit, gets you there very quickly. It's about a 3-hour flight from the time of liftoff up to the space station, and it's actually the service module and crew module that get it all the way there. So the Atlas phase of flight ends after about 15 minutes. So our jobs at ULA is to get the Starliner on the right trajectory headed toward the space station. We provide them a really, really big boost to get them there, but we don't get them all the way there. Again, our booster phase of flight is about 4 minutes. Centaur then is about 8 minutes, and then the whole thing, we've separated them and sent them on their way about 15 minutes after we lifted off from Cape Canaveral. So our actual portion of the mission's fairly short, but very critical. And then the service module will fire its engines and take it the rest of the way to space station, and then they'll dock. And of course, the last piece of the mission is very, very slow as they dock at something like 1/10 of an inch per second or something. Don't quote me on that, but it's very, very slow as they creep up to the space station and dock. So what does that look like? Here's the Starliner docking at the space station. Again, about 3 hours after liftoff, it will reach the station. All the docking is autonomous. Very few switches actually flipped by the astronauts on board. They'll be able to sit back and relax as the Starliner docks them to the station. And then I don't think they'll really be relaxing, but they will be letting the spacecraft do a lot of the autonomous work, which is great. And then they'll fly missions that are a lot like the shuttle was. So it'll be 7 to 10 days, be meeting the needs of the ISS with its scientific objectives, experiments, other things, changing out crew, taking cargo. The nice thing with the Starliner is that it can take both crew and cargo. So depending on what the mission is, they'll say, all right, we're sending one up. We're going to take care of the astronauts first, and then whatever performance is left over, we'll fill it up with cargo and get the cargo up there as well. So that's a nice capability, and that they can take a lot of the supplies that the space station needs with them. And then again, they'll stay 7 to 10 days, somewhere on that order, and then the capsule will come back. It'll land on dry land. It's not going to land in the water. It uses a series of parachutes, airbags, retro rockets to come back on land. There's several primary landing sites throughout the U.S., Yuma, Arizona, Wilcox, Arizona, Dugway, Utah, White Sands Missile Range in New Mexico. And what's great about landing on land is that, one, there's several sites that they've chosen, so they can check the weather, the operations, what's the best site to bring the astronauts back, land them on dry land. You don't have all the extra operational challenges that come with being in the ocean and getting boats and helicopters out there. They're right there. You can drive up to them in a four-wheel drive. You're in the middle of the desert or a dry lake bed, and go up and retrieve them. If you've ever seen a Soyuz capsule come back, you see that it lands on the land and all the vehicles swarm around it. So we're looking at something similar to that. And then they can ship the spacecraft back to Boeing for refurbishment. It can be used up to 10 times. And it's also, in its early design, has been already designed, I'll say, to do longer duration missions. So even though the original, or the initial intention of commercial crew is to do, a week to 10 days up to the space station and back, Boeing's already thinking about what to do to make longer duration missions possible. So deeper space, further human exploration. And with the landing as well, the other good thing about the airbag combination with the retro rockets is it should be fairly soft. People talk about the Soyuz and how sometimes violent that is, but with the airbags, it will be a much smoother ride for the astronauts, so it should be very good for them. So with that, I'm going to play a little bit more smoke and fire, because rocket launches are really cool, exciting to see. So just got a really short video to kind of sum up ULA and commercial crew and watch a few more cool rocket launches, and then I'll be back. So again, it highlights the 118 successful missions, the 100% mission success, the core principles that we're carrying in to commercial crew. I mean, at ULA, we can't express how excited we are to be able to be given the honor to launch astronauts. I think we were chosen because of our success record, our great heritage, and it's those principles that we're carrying in that are going to launch astronauts in just over a year. So when you think by that time it's going to have been a 7-year drought since the shuttle, it will have been 7 years since an astronaut has left US soil and flown to space. And so to be part of the team that gets to return them is extremely exciting. And so we again know that this is a new first, something that has not happened in 35 years. And so we couldn't be more excited about it. And to think that astronauts will actually be back on Atlas in just over a year is just very humbling to think about. I wanted to go back to the question I had at the beginning about if I was more surprised by seeing Saturn's rings or that I got my wife to go with me to astronomy club. And I didn't share the answer at the beginning, but I'll share it now. And the answer is, I was more surprised by Saturn's rings, absolutely. I was not surprised that another human being wanted to look at the stars. I think that there's 7 billion of us on the planet, and we are all astronomers. Certainly some more amateur than others, but I think that we all look up at the stars and wonder what else is out there. And we may have different answers, but we all have the same question. So to think that somebody was excited by that, wanted to go see the stars, should not be surprising because we all have that curiosity, which is great. To be able to be at ULA and launch science missions to all the planets in the solar system, telescopes that are finding new galaxies, rovers that are exploring Mars, Pluto missions. You guys have had Alan Stern here. We launched the Pluto mission that just arrived last year and is getting excellent data back from Pluto and the Kuiper Belt. We launched the Juno mission. You had Scott Bolton here yesterday. And so to be able to take it a step further and not just look through a ground-based telescope, but put an asset on orbit or out to another planet to explore it even deeper is really, really exciting. We get to also now to think about, we've launched all these great uncrewed satellites, all these robotic missions, and now we're going to push people closer to the stars, closer to the planets. We're going to be able to have them get to low Earth orbit, but again, that's just a stepping stone. The Boeing CST-100 Starliner is built for deeper space missions. So this is a great return. This is an opportunity to start pushing humans back into space. I think there's more momentum behind manned spaceflight, human spaceflight today than there has been in probably 40 years. So the momentum's back. We're ready to go launch to low Earth orbit again, and then we'll see what's after that. Certainly hope that it's an asteroid, that it's the moon, that it's Mars, and that we continue pushing humans further. So with that, thank you very much.
closer look.
Awesome!
We can take a picture of it too.